All right, welcome to Mr. Baker's House of Knowledge. Getting ready to learn a little bit about some theorems about angles. First angle we're going to talk about is the vertical angle theorem. So the vertical angle theorem first means that you need to be able to identify from a drawing what angles are vertical angles. So I'm going to put a little picture up here, right here, involving angle A, or points A, X, B, C, and D. I want you to get with your table partner right now, and I want you and your partner get together and identify two vertical angles out of this drawing. So two angles that are vertical angles could be the angle AXD and angle BXC. So how would we write that? Angle symbol AXD, remember the vertex is always in the middle. Angle symbol BXC. So here's a little bit of review for your Unit 1 retest right there. Knowing how to label an angle, it requires 3 letters. The middle letter is your vertex. And so those two angles would be vertical angles. That's the yellow angle and the green angle. The yellow and the green angle are definitely vertical because their opposite sides form straight lines and they share a vertex. Does anybody have any question about what a vertical angle is? Yes?
Could it be AXB and DXC?
So could we have different vertical angles? And the answer there is yes. We could have a situation where we looked at the top, AXB, and the bottom, CXD. So yes, you could have said that this angle right here was vertical to this angle right here. And that's fine. So just as long as you give me a pair of vertical angles, that's fine. All right, so now that we've identified them as vertical angles, we have a theorem that says if you know about vertical angles, then those angles will be congruent. Angle AXB is congruent to angle DXC. Why? Because those angles are congruent. So I could write that as angle AXB congruent to angle DXC. And then I could even go back and apply the definition of congruency and say that their measures are equal as well. So the takeaway, the point I'm trying to explain here is I can visually inspect a drawing and decide if the two angles are vertical. If I visually look at a drawing and decide that the two angles are vertical, then I can say they're congruent. Always. There will never be a situation where that's not true. This is useful because it can then allow us to set up and solve equations. In this particular problem right here, I can visually inspect this drawing and see that 4x and 2x plus 21 are vertical angles. So since I know that they're vertical angles, I can then say 2x plus 21 is equal to 4x because vertical angles are congruent, and by the definition of congruency, congruent things are equal. And then now I can use algebra to solve. I'll go through and subtract 2x from both sides. So subtract 2x from both sides of the equation, and I will get 21 is equal to 2x. And then I will undo multiplication by using division, divide both sides by 2, and I'll get my answer. X is equal to 21 halves. Can I leave it like that?
Yeah.
Sure, why not? Also, if you want to, you could change it to decimal form. I don't mind you changing answers to the decimal representation, just so long as you don't have a repeating decimal. So I wouldn't want to change 22 over 3 to 7.333333. But I'm okay with you changing 21 over 2 to 10.5. Do you see the difference there? Good. Any further questions? All right, what I'd like to do is I'd like you to work out this problem and then share your answer with your table partner. All right, so what is the solution here, Jonah? So he says x is equal to 40. Now, I could check this by plugging 40 in. 3 times 40 is 120. 2 times 40 is 80, plus 40 is 120, and they come out to be the same. But we might want to see our work and how we work this problem. Brian, how would you have set this one up? Okay, because they're vertical angles, you know they're congruent, and since they're congruent, they're equal. So 3x is equal to 2x plus 40, and then we just subtract 2x from both sides, and that isolates the variable and solves it for us. This was a pretty easy one-stepper. Everybody okay with that?
Yes.
All right, moving right along. I'm going to go through a series of theorems for you, and these are great make note card things. So the first note card you should probably take away from this one is vertical angles are congruent. So I would put vertical angles are congruent on the front of the note card, and then on the back of the note card, I like the way the book has this broken down. It's got it in kind of an if-then situation. So I would put on the back, well, we don't have an if-then right here. So on the back, I would just put a drawing and then say that the two are congruent, maybe even mark them congruent. Vertical angles are congruent. Here, on the front of the card, I would not put Theorem 2-2. That is not good etiquette because this book has decided to put this theorem at this location within the book, and that's just a book reference. That's not anything of real mathematics there. Here's what I would put on the front of the note card. If it has a title, put the title. Congruent supplements theorem. All right. What the congruent supplements theorem says in words is if two angles are congruent, if two angles are supplementary to the same angle, they will be congruent to each other. Or to even extend that out, if two angles are supplements of the same angle, or if they're both supplements to two other angles that are congruent to each other, then those two angles will be congruent. So what does that mean? Well, here we have angle 3, angle 1, and angle 2, and we know that angle 1 and angle 3 are supplementary. So if I were to write that as an equation, how would that look as an equation? How would you write an equation with two angles that are supplementary? What does supplementary mean?
Equals 180.
What equals 180?
It's sum of the
Oh, so sum. So I'm going to put a plus symbol. I'm going to put an equals 180. And since I'm talking about the two angles, I'll call it the measure of angle 3 and the measure of angle 1. All right, so let's solve for the measure of angle 1. What would I get? How do you isolate the measure of angle 1? What do you need to do to get rid of the measure of angle 3? Right. So you could think about getting rid of, in terms of variables or numbers, I can subtract the measure of angle 3 from both sides of the equation, and I'm okay with that. So when I subtract the measure of angle 3 from both sides of the equation, I get that the measure of angle 1 is equal to 180 minus the measure of angle 3. Does that make sense? Any questions about that? All right. Then the measure of angle 2, or 3, plus the measure of angle 2 is also going to be 180. Why? Because angle 2 and angle 3 are supplements. So if I were to subtract angle 3 from both sides, I would have the measure of angle 2 is equal to 180 minus the measure of angle 3. Holy smokes, look at this. This right here is the exact same thing as that right there. So by substitution, if I replace 180 minus the measure of angle 3 with the measure of angle 2, which I can do because the measure of angle 2 actually equals that, and substitution lets you replace one thing that equals it with another, I would come up with the measure of angle 1 is equal to the measure of angle 2. And if they're equal, it means they're congruent by the definition of congruency. So I'm kind of giving you a little mathematical mini-proof right here. So, congruent supplements theorem says, if two angles are both supplementary to the same angle, they'll be congruent to each other. If you think about it, that makes sense. If this is 110, what's the supplement? What number do you add to 110 to get 180? 70. So 1's the supplement, that makes 170. 2's the supplement. That makes 2 70. Oh, what a coinky-dink. They're both 70. That means they're congruent. We okay with that? Okay. I'm not going to go into as much detail, but there is a congruent complements theorem as well. And the congruent complements theorem in your brain works exactly like supplementary, except instead of doing angle plus angle equal 180, it's angle plus angle equals 90. One very unconfident person responded to that question, so let me try that again. In complementary angles, angle 1 plus angle 2 equals
90.
There you go. That's what I like to hear. So that means if 2 were 50, what would 1 be?
40.
What would 3 be?
40.
Because 1 and 3 are complementary, they have to add up to be 90. Hey, what a coinky-dink. They're both the same. So on your note card, congruent complements theorem, and then maybe I put the if-then on the back. All right. Theorem 2.4 is really a theorem that doesn't have a title. So instead of a title, we're just going to have to write what it is. On the front of your note card, on front of your note card, write all angles are congruent. And you can abbreviate if you want to. All angles are congruent. There's some good abbreviation. Not really abbreviation so much as I use symbols to represent words. But isn't that really what abbreviation is? All right, so angle 1 and angle 2 are right angles. All right angles are congruent. Therefore, I know angle 1 is congruent to angle 2. On the front of your note card, all angles are congruent. On the back, put the if-then. Finally, we've got Theorem 2.5, which also doesn't have a title, unfortunately, and it's also a little wordy. So what I'm going to do is I'm going to give you a little in-depth explanation of this one.
Who came up with all of these?
Some math guy, probably Pythagoras. I hear he was into writing theorems. All right, so this one is, if two angles are congruent and supplementary, then each is a right angle. I would write, if an angle is both congruent and supplementary. It's not going to be a P.
This is for all angles are congruent.
This is for Theorem 2.5. This is what I would call it. This is what I would title it. If an angle is both congruent and supplementary, because if two angles are congruent and supplementary, that means they're both supplementary and congruent, or both congruent and supplementary. So, if this situation exists, all right, so if I were to write an equation, Michael, saying that two angles were supplementary, let's say I'm talking about angle 1 and angle 2, what would that look like?
So wouldn't they both be 90?
That's what he said.
Well, yeah, they will both be 90. I'm going to prove why. So, Michael, what does supplementary mean?
180.
They both add up to be 180. So the supplementary part of the statement says that the measure of angle 1 plus the measure of angle 2 is equal to 180. Is everybody with me? That's what supplementary means. So I know I've got angles that are congruent and supplementary. I'm just dealing with the supplementary part. What does congruent mean? They would equal each other. So the measure of angle 1 would also equal the measure of angle 2. Now remember, if both of these things are true, then that means in this equation, I can change the measure of angle 2 to the measure of angle 1. So that would be like the measure of angle 1 plus the measure of angle 1 equal 180. Would you agree with that? Michael, can I replace angle 2 with angle 1?
Yeah.
Yes. And now I'm going to try to add these two angles together. What happens when you add the measure of angle 1 to the measure of angle 1? Well, I mean, yeah, besides the fact that it's 180. Let's pretend like I can't see this side of the equation right here.
Well, it's the same length.
Simplify the measure of angle 1 plus the measure of angle 1. Now, hold on, somebody said it? What?
Measure of angle 2.
No. Angle 1 plus angle 1 doesn't equal angle 2.
But angle 1 is angle 1, so therefore.
Okay, so this is a little bit confusing until you think about it in the right way. What if I told you to say add x plus x? What's x plus x? What? 2x. Okay, so you were saying the measure of angle 2. And the measure of angle 2 is like y. So you were saying x plus x equals y, which in this case is not true at all. X plus x is equal to 2x. So the measure of angle 1 plus the measure of angle 1 is twice or 2 times the measure of angle 1. Does that make sense? And so that's still going to equal 180. I just simplified. And now, can I solve for angle 1? And so what would it look like when I solve for angle 1? Divide both sides by 2 and I would get 90. So if angle 1 and angle 2 are equal to each other, and angle 1 is equal to 90, then what must angle 2 also be? So basically what this theorem is saying is, if the angles are the same, and they both add up to be 180, there's only one number they could be, that's 90. There's only one number that's the same as itself and adds up to be 180. By the way, this is a system of equations. I had 2 equations and 2 variables. I substituted in for one, solved for that variable, then I back substituted to find the other. So that algebra that we've been reviewing, we just applied it right here. All right, so that's all I've got for you. Let me just put up a quick example and let's see if we remembered what we talked about at the very beginning of class. So I'm going to say that's that, I'm going to say that's that, and I'm going to say that's that, and then I'm going to say angle 1, angle 2, angle 3. What would be the measure of angle 2?
90.
90. How did you know that? Because it's vertical with this right angle. What's the measure of angle 1? 50. Because angle 1 is vertical with 50. What's the measure of angle 3? 40. You got it.